today is concept 6b, and we're talking about deductive reasoning. First, let's talk about the difference between inductive reasoning and deductive reasoning. Inductive reasoning uses patterns or observations to make a conjecture, which is an unproven statement. So this is what we did yesterday, where you looked at patterns, you named like the next three numbers or the next three in the pattern. You're using those patterns to make what you think is going to happen, which is called a conjecture. Deductive reasoning is more concrete. It uses facts, definitions, and properties to draw conclusions. So let's talk about a conditional statement. A conditional statement is an if-then statement. The if part is called the hypothesis. You may have actually used this before in science, written conditional statements. The then part is called the conclusion. And when we're writing hypothesis and conclusions, conditional statements, a lot of times you'll see this if P, then Q. So P stands for the hypothesis, and Q stands for the conclusion. If P, then Q, those are the letters that you'll see used. So in this first example, test the validity, if it's true or false, of this conditional statement. If Jan lives in Missouri, so that is the hypothesis, then she lives in Liberty. That's the conclusion. So I'm asking, is this true or false? Well, if you live in Missouri, then you don't have to live in Liberty, right? If you live in Missouri, you could live in Gladstone or Kansas City or even like St. Louis. There's lots of places you can live in Missouri. You do not have to live in Liberty just because you live in Missouri. So this is false. And then give a specific counterexample. False because you can live in other cities in Missouri like, let's say, Gladstone. So that's a counterexample because I told you, okay, this is false because I can find a time when it's false. If Jan lives in Gladstone, then she still lives in Missouri. So a counterexample is a statement that proves a conditional statement is false. And it needs to be very specific. So tell me a specific time when it's false, like you can live in Gladstone and live in Missouri. Okay, moving on to our next thing today is called the converse. If you switch the hypothesis and conclusion of a conditional statement, you get a converse. So you will just flip the order. And that gets you a converse. All right, here's an example. So the conditional from before was if Jan lives in Missouri, then she lives in Liberty. The converse is that you flip that. If Jan lives in Liberty, that's first now, then she lives in Missouri. So let's think about that one, if it's true or false. If she lives in Liberty, then she lives in Missouri. Well, that's true, because if you live here in Liberty, then you also live in Missouri. So we'll say because Liberty is in Missouri. If you live here, then you automatically live in Missouri. So that's true. All right, let's circle the hypothesis and underline the conclusion on the conditional below. If G is on AB, then G is also on BA. Circle the hypothesis and underline the conclusion. So my hypothesis is this first part. that comes after the if. Notice I did not circle if because the hypothesis is that G is on AB. Then conclusion. G is also on BA. So when you go to look at conditional statements, remember it's if, hypothesis, then conclusion. Now we're going to decide if this one is true or false. So let's draw a picture. If G is on AB, so I'm going to make a line, put AB here. If G is on this ray, so I'll go ahead and put G right there. If G is on ray AB, then it's saying it's also on BA, which would go this direction. Well, that's not necessarily true, because to be on AB, it doesn't have to be in between them. So this is false because of what we see here. So this picture, false because, let's explain it, G does not have to be in between A and B. So all you're doing when you're trying to find a counterexample is find one time when it doesn't work. If you can find one time when it doesn't work, then it's false, even if other times it would be true. So the converse of that, we flip it. If G is on BA, then it is on AB. All we did was flip the hypothesis and the conclusion from up here. We flipped the order, and that's what gave us the converse. So in the very last thing, I want you to write a conditional that is false, so an if-then statement that's false, but a converse, the flip of it, that is true. I'm going to use one in geometry. We'll say my conditional statement, this is false. If a figure is a quadrilateral, then it is a rectangle, which is false because there are other quadrilaterals that are not rectangles, right? Like trapezoids and parallelograms, kites, rhombuses. There are other things that are quadrilaterals that are not rectangles, so that's false. And the converse of that, if you flip it around, so reverse the order, if it's a rectangle, then it is a quadrilateral. That's true, because to be a rectangle, you have to have 4 sides. So if you are a rectangle, it automatically has 4 sides. So this is the one where the conditional is false, but the converse is true.